Hi everyone, and welcome back to Math with Professor V. In this video, we're reviewing AP Calculus Unit 2 on differentiation. We'll go through the definition and basic derivative rules. And we're going to cover the major topics that the College Board expects. So limit definition of the derivative, finding slopes of tangent lines, estimating derivatives from tables and graphs, differentiability and continuity, and then all the fundamental derivative rules, your power rule, product rule, quotient, trig, exponential. I'm going to work through even some real AP exam questions so you can see exactly the level and style to expect. So let's dive right in. And then if you need a more in-depth lecture on any of the topics discussed in the video, then watch the rest of the videos on this AP Calculus Unit 2 playlist here on my YouTube channel. Okay, first topic we're going to go through deals with average and instantaneous rates of change. So let's revisit what the definition is for the average rate of change of a function on an interval. So this is something hopefully you looked at a little bit in pre-calc in your previous math classes. When you're looking at what the average rate of change is for some function f of x on an interval from a to b, you find it by taking f of b minus f of a over x minus a. And no surprise, this should remind you of your slope formula because that's exactly what it is. And so when you're looking at the average rate of change of some function, and if we're thinking in terms of its graph, let me just do something cute and relaxing in quadrant 1. So here's f of x. Say this is a and this is b. The average rate of change, yes, is the slope of the secant line that goes through f of x, f of a, and f of b. Okay, so the slope of that secant line also gives us the average rate of change. Notice when you're finding average rate of change, you need 2 points. Then what we start talking about now that we're in calculus is instantaneous rate of change. Well, what's the difference? Instantaneous is at an instant, not over some period of time. So when you're finding instantaneous rate of change, it's going to be of f of x at not some interval, at one single point, x equals a. So instead, what we need now is to take a limit. Oh, that's why we learned this in calculus. As x approaches a, of f of x minus f of a over x minus a. And while the average rate of change was represented by the slope of the secant line, the instantaneous rate of change is represented by the slope of the tangent line. So if you were to draw a tangent line to your curve here, its slope, ba-boom, would be the instantaneous rate of change at that point. Okay, so we're going to talk about how to evaluate derivatives when you're given the equation of a function later, but right now we're going to estimate it using tables. We're going to estimate the average rate of change and the instantaneous rate of change. And this is a classic AP style question. You guys, I took the AP calculus exam over 20 years ago, and a lot of stuff is still similar. They love this one. Okay, so the table shows the position of a motorcyclist after accelerating from rest. Top row tells you how many seconds it's been since he was at rest, and then S measures the number of feet. We often use S to measure position, okay? So find the average velocity for each time period. So we're first going to look at the interval from 2 to 4 and then 3 to 4. So average velocity, remember, average velocity is the average rate of change of the position function. So if S is measuring the position, average velocity would be S of B minus S of A over B minus A on the interval from A to B when S of T measures displacement or position. I'll just say position, not displacement. That's something else. Pretend I didn't say that. Okay. So find the average velocity from 2 to 4. We would take S of 4 minus S of 2 over 4 minus 2. And then just come here, use the table. So S of 4, 79.2 feet. S of 2, 20.6 feet. Divided by 4 minus 2 is 2. So this is 29.3. And then don't forget your units. Now it's going to match Notice in the numerator, we were measuring feet. And in the denominator, this is measuring t, which is seconds. So put that on there. Feet per second. Okay? Very good. Next one. Now we're looking at the interval from 3 to 4. So same thing. S of 4 minus S of 3 over 4 minus 3. So this is going to be 79.2 minus 46.5 over 1. And you should get 32.7. Again, feet per second. Don't forget the units. How are we doing? Okay, good. Now, the next thing they ask us to do is estimate the instantaneous velocity when t equals 3. Instantaneous velocity when t equals 3. So what you want to do is, we have to estimate it using average velocities. I'm going to find the average velocity for two evenly spaced intervals around, in this case, t equals 3, and I want those intervals as tight as possible. So I'm going to get the average velocity from 2 to 3, and then the average velocity from 3 to 4, and take the average of those two averages to estimate the instantaneous velocity, okay? And you want to pick the tightest interval possible. So had they given me 2.5 and 3.5, I would be using those values instead. You don't want to say like, let's check from 0 to 3 and from 3 to 6, because it allows for too much variability. If you're looking here, if you're going to use this, average, the secant line slope to estimate the tangent line slope, you want to get as close as possible. You want a tighter interval, because that's when the slope of the secant line starts approaching the slope of the tangent line more closely. Okay, that's a whole nother discussion. But anyways, let's just jump right into it. So here's the game plan, guys. We're going to average the average velocities from 2 to 3 and 3 to 4. Now, thankfully, we already have the average velocity from 3 to 4. Boom, we have it. Great. So then now I just need to figure out first average velocity from 2 to 3. Let's do that now. So that'll be S of 3 minus S of 2 over 3 minus 2. So that's 46.5 minus 20.6. Good? Okay. Over 1, which gives me 25.9 feet per second. Okay, that's not our final answer. I'm going to take this value and average it with 32.7, meaning I'm going to add them together and divide by 2. So 32.7 plus 25.9 divided by 2 gives me 29.3 feet per second. Okay, very good. Make sure you know how to do this. They love putting a question like this on there. Okay, next example, finding the derivative of a function and using derivative notation. So here we're going to let f of x equal the square root of x plus 2. And first we're being asked to use the limit definition of the derivative to find f prime of x. Obviously this would be something on the free response portion, because how else would they check that you use the limit definition? So hopefully you remember the limit definition of the derivative and you use excellent notation. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, you have to keep writing lim as h approaches 0 until you actually evaluate the limit. So here, in the numerator, this is the trickiest part for students. F of x plus h means I'm going to replace x with x plus h. So underneath the radical now, I'll have x plus h plus 2 minus f of x is just the original square root of x plus 2 over h. Now, if you try direct substitution and plugging in h is 0, you'll get 0 over 0, which is an indeterminate form. Anytime you're doing the limit definition of the derivative and you have radicals, you're going to need to multiply by the conjugate in order to get rid of the radicals and clean up. So we have the conjugate of the numerator would be the exact same two radical expressions. You're just going to change the sign in between them to be plus now, okay? And keep in mind, your goal to evaluate this limit is always to get rid of this h, this pesky little h in the denominator. Once you can cancel him out, then you can take the limit. Yeah. So here we go. In the numerator, we're not going to have any more radicals, right? Because when you have conjugate pairs multiplied out, you get a difference of squares. So we're just going to have a squared, which would be x plus h plus 2, minus b squared. Just don't forget parentheses, otherwise it'll ruin your life. X plus 2. I'm not being dramatic, it will. Okay, over. Don't multiply out the denominator. Don't multiply out the denominator. Say 99% of the time in your math career, you don't need to multiply out the denominator. Okay, now we have ourselves a little cancel fun. Cancel party. Cancel the x's, cancel the 2's. I still have an h in the numerator. So limit h goes to 0, h over h times square root x plus h plus 2 plus square root x plus 2. Perfect. Love it. Well, we're almost home free. It's time to cancel the h at long last. Don't forget, now you're going to have a 1 in the numerator. So this is the limit as h approaches 0 of 1 over the square root of x plus h plus 2 plus the square root of x plus 2. Now I can take the limit. Now I can substitute in 0 for h, and I don't write lim anymore. The limit was as h is going to 0. As soon as there's no more h's in here, stop writing it. So this would be square root of x plus 2 plus square root of x plus 2, which would be 1 over 2 square root x plus 2. Bravo. That is, don't forget, f prime of x. You're like, who were we finding? It's been so long. Okay, beautiful. Box it with immense pride. That's a job well done. Okay, now we're going to need to find the equation of the tangent line to the graph of f at x equals 7. Well, good thing we already have the derivative, because the slope of the tangent line is going to be f prime of 7, so I can figure that out. No big deal. 1 over 2 square root 7 plus 2. That's going to be square root of 9, which is 3. So this is 1/6. Okay, perfect. Now to write the equation of a line, I need a slope. I got it. And then I also need a point. Well, where can I get the point from? They told me x is 7. So I need to know what is f of 7, the original function, not the derivative. F of 7 is square root of 7 plus 2, which is 3. So the point is 7 comma 3. So just use point slope form now. Then you should be on your merry little way. So we'll have y minus 3 equals 1/6 times x minus 7. And then let's see, this is y minus 3 equals 1/6 x minus 7 over 6. Add 3. Add 3. So we need to get a common denominator. That's going to be 18 over 6. So we're going to end up with y equals 1/6 x plus 11 over 6. How are we doing? Are you guys okay? Yes? Very good. All right. Now let's look at some other examples. This sort of thing you might see on the multiple choice portion. Each limit represents the derivative of some function f at some number a. State such an f and a in each case. So what you need to do is remember the limit definition when you're finding the derivative of a function at a point. So in this case, we would look at the limit as h approaches 0 of f of a plus h minus f of a over h. Only difference is from the last problem that we did, we have a fixed number, and we instead this last time here left it as x. So this time our derivative was a function of x. In this case, if we finished off the limit, you would get some constant value, okay? So don't freak out. This is obviously f of a plus h, and then this is f of a. Let me color code for you. Okay, so take a guess and then see if your guess works out. So I'm going to guess f of x looks like it's going to be the square root of something, right? Let me just leave it, square root of x. And then think backwards. If f of x is square root of x and we got 3 as the output, as the y value, what was x? well, that's what a is. So in this case, a is 9. So double check, is f of 9 going to give me that square root of 9? Oh yeah, it does. And then if you plug in f of a plus h, that would be square root of 9 plus h. So there you go. So they just want f and they want a. F of x is square root of x and a is 9. You're just going backwards figuring out what was the function and what was a. Okay, let's look at one more. Oh no, my students hate these. They hate them, but I'm like, they're not that much work. Please don't hate them. All right, again, this is f of a plus h, and then this is f of a. So take a guess. If f of a plus h, hold on, f of a plus h is cosine pi plus h, I mean, good chance a is pi, right? And then f of a is 1. Okay, I'm going to guess. F of x is cosine x. Is f of pi, if pi is a, cosine pi is negative 1. But there's a positive 1. Yeah, I know that's correct because it's always minus f of a. So if that's negative 1, that's why it became positive. So we're good. They can't stop us. We get them all right. A is pi and f of x is cosine x. Okay, if you need more practice with those, let me know. I have a bunch. I just figured 2 was enough. Okay, more working with tables. I'm telling you, they love this topic on the AP test. So estimating derivatives from tables and graphs. The table gives the number n of t measured in thousands of minimally invasive cosmetic surgeries performed in the United States for various years t. So here's the years, and then n of t is being measured in thousands. So first, what is the meaning of n prime of t and what are its units? So notice they're asking us to interpret the derivative. Keep in mind derivatives are rates of change of the function that they're the derivative of. So in this case, how would I answer the question? I would say n prime of t is the rate at which, and then what is n measuring? Oh, minimally invasive cosmetic surgeries. Okay, the rate at which the number of minimally invasive cosmetic surgeries, cosmetic surgery procedures, should we be that precise? Sure, whatever. Performed in the, I don't like stuff like this. I'm like, it feels too much like English class. Okay, performed in the US is changing. It's always rate of change. In this case, with respect to, what's the independent variable? Time. And then what are the units? It's the units of n of t divided by t. So that would be thousands of surgeries per year. T is being measured in years, yes? Okay. Whew, we got that over with. Okay. Construct a table of estimated values for n prime of t. So we're going to do this the same way that we estimated the instantaneous velocity in that first problem, okay? Now, remember how, if you look back at that first problem, when we estimated instantaneous velocity, it was t equals 3. We took average velocity from one interval on either side, basically. One interval below, one interval above. And we're just going to do that over and over and over, okay? What do you do when there's no values below it and you don't have an interval on the other side? You just use the average rate of change to estimate the instantaneous rate of change. Okay, so that's just like the best that we can do, unfortunately. So I'll do one example for you. It's obviously going to take a long time to do the whole table, but I'll just do one so you get an idea. I'll start with a nice one. We'll do 2002, okay? So to estimate n prime of 2002, we're basically going to look at average rate of change, right, on two intervals on either side. So I'll estimate it with, you see how they're all spaced out by 2's? So h equals -2 and h equals 2. So if we're using h as -2, then n prime of 2002 is approximately, you go 2 below, n of 2000 minus n of 2002 over 2000 minus 2002. And then this gives you 5,500 minus 4,897 over negative 2, which is negative 301.5. Then use an interval on the other side. So now we'll do h is positive 2. So n prime of 2002 is going to be approximately n of 2004 minus n of 2002 over 2004 minus 2002. Okay, you can read the table, and that'll be 1286.5. So then from here, I'm going to average those two. So, and that'll just improve my estimate. N prime of 2002 is approximately 1/2 of negative 301.5 plus 1286.5, which is 492.5. Thousands of surgeries per year. Okay, so this is what we're going to use. And you just repeat the process. So you're going to get 2 average rates of change, average those, and then that's n prime at that year. So we just did average rate of change from here to here, average rate of change from here to here, averaged those, that's n prime of 2002. Then you would repeat, you'd move on to the next one. So if you wanted to do 2004, you would do average rate of change 2002 to 2004, 2004 to 2006, average those, there's n prime of 2004. So obviously they wouldn't ask you to do like a whole table like this on the AP exam because it would just take too long. They're just going to want to see if you know how to do it for like 1 or 2 values. Only funky thing is, like I said, we have no values of t below 2000. So to estimate the derivative there, you just have to use this interval. So I'll tell you what the values are if you want to sit there and work it out on your own, because I think it would be really good practice for you to make sure you get the idea, okay? So I'm not going to sit here and do the whole thing. And then also, I'll just make a note, that way you're not freaking out. So for 2000, you're just going to use that n prime of 2000 is approximately negative 301.5, the only average rate of change that we have from earlier. Okay, and obviously you'd have to do that also for 2012 because there's nothing on the other side. Same for 2012. But if you want to sit there and work through a few of them, make sure you know how to do it. Let me tell you what the rest of the values will be, okay? So t, n prime of t, and just make sure you know your units. I don't know, I never liked these. I didn't want to say that and make you guys not like them. They're not hard. It just made me nervous. But anyways, so yeah, I took AP Calc so long ago, and some of the stuff my calc teacher told me then I still use, like the song for the quotient rule I'm going to tell you guys right now. Well, I won't torture you by singing, but I use it every time I do the quotient rule. I recite it to myself, and hopefully I'm copying these down correctly. All right, good. You can work on those on your own later. All right. Next topic, connecting differentiability and continuity, determining when derivatives do and do not exist. So we know differentiability is a stronger condition than continuity. So if we know that a function is differentiable at a point, that implies that it is continuous there. The reverse statement is not true. However, the contrapositive is true. What is the contrapositive? When you negate both and you reverse the order of the statement. So not continuous implies not differentiable. Okay, this is a classic question. This is straight from an old AP test. So the graph of the piecewise defined function f is shown in the figure above. The graph has a vertical tangent at x equals negative 2. Can you see? Right there. And horizontal tangent lines at x equals negative 3 and x equals negative 1. Yeah, nobody cares about those, okay? What are all the values of x between negative 4 and 3 at which f is continuous but not differentiable? So a function would be continuous and not differentiable as long as, you can just think of your pre-calc definition, can you trace the graph without lifting your pen? But, so that means it's continuous, but it would fail to be differentiable because there's a vertical tangent or some sort of cusp or sharp point, okay? So So let's discuss everything that's, interesting. The horizontal tangents, nobody cares. That's fine. They're just throwing that in there to get you confused. It's continuous and differentiable. The derivative is just 0 there, so tell them to relax. Okay, here at x equals -2, the function is continuous. It passes all 3 conditions for continuity. I know that because you see how the stylus is right here and I'm not lifting it? Great. But it's not differentiable because we have a vertical tangent. So x equals -2. It's continuous but not differentiable. Okay. We're tracing, everything's good. Horizontal tangent here, nobody cares. That means derivative is 0. Okay, that's differentiable. 0 is a number. Don't freak out. Coming here. Oh, wait a minute. I have to lift my pen to trace the graph. If I have to lift it, that means it's not continuous. Notice the limit from the left doesn't equal the limit from the right. Therefore, the limit doesn't exist. So this fails a condition for continuity. If it's not continuous, it's not differentiable there. So I'm not going to include x equals 0 in my answer because what are they wanting? Where f is continuous but not differentiable. Well, it's not even continuous here. So don't include x equals 0. That's not the criteria they're looking for. Keep going. It's continuous, but see how there's a sharp point? There's a cusp right here. The slopes of the tangent lines from the left do not equal the slopes of the tangent lines from the right. So that's why it's not differentiable there. But it is continuous. So at x equals 1, it's also continuous, but not differentiable. So those are the only 2 x values. Don't let any of the others trip you up. Oh, it's C. There we go. Okay, moving on. Last topic deals with differentiation rules, the power rule, product rule, quotient rule, and trig derivatives. So I'm just going to go through some examples quickly. Make sure you memorize these rules. For the quotient rule, quotient rule, I learned it as high over low, like the numerator you call high, denominator you call low. So f prime of x would be low d high minus high d low over low, or square the bottom, away you go. So when we say low, that means just put the denominator. D high means derivative of the numerator. Minus high, D for derivative of the denominator over low. Okay, here we go. So y prime is going to be, and I mentally recite it to myself every time I do this. Y prime is going to be low, leave the denominator alone, d high, derivative of the numerator, 2x minus 3, minus high, d low, derivative of the denominator, 7x to the 6th, over low. Don't multiply it out. Just write it squared, move on with your life. Then multiply out everything in the numerator, and then we'll see if we can clean up. So we'll have 2x to the 8th minus 3x to the 7th minus 4x plus 6 minus, don't forget your parentheses, 7x to the 8th minus 21x to the 7th plus 14x to the 6th over x to the 7th minus 2 squared. And then, yes, we can combine some like terms. So we'll have negative 5x to the 8th plus 18x to the 7th minus 14x to the 6th minus 4x plus 6 over x to the 7th minus 2 squared. Beautiful. Notice all the calculus happened just in this first step. The rest was cleaning up in your algebra. So make sure if you need to review any basic algebra, you do so. Okay, r equals square root of theta minus 3 over square root of theta plus 3. I'm going to teach you a shortcut. When you take the derivative of the square root of x, okay, remember you're taking the derivative. If you do it the long way, you write it as x to the 1/2, then you bring the 1/2 down front, you have x to the negative 1/2, and then when you clean it up, it's 1 over 2 rad x. I think later in the next unit, you're going to learn the chain rule, and I'll teach you a shortcut when you have to do chain rule with square roots, and it's helpful. If you just remember square root of x's derivative is 1 over 2 square root of x, it'll just save you time. You can cut this out. Unless your teacher's going to get mad at you. I don't know. I hope they don't. Okay. R prime of theta equals quotient rule time. So we have low D high, derivative of the numerator, derivative of square root of theta would be 1 over 2 square root of theta, and then derivative of a constant, 0. Minus high, D low is the same, 1 over 2 square root of theta, over low, square root of theta plus 3 squared. Now get in this habit when you're cleaning up from quotient rule, you want to factor out anything that you see in common, okay? So let me take out 1 over 2 square root of theta times square root of theta plus 3. And then if I distribute, do you see this negative? Yes, distribute with care. It'll be minus square root of theta plus 3 all over square root of theta plus 3 squared. Okay, let's see. So these square root of thetas cancel. And then I have 3 plus 3, so that's 6. And then let me just put this guy in the bottom, right? Yes, 6 over 2 square root theta times square root of theta plus 3 squared, and then just cancel 2 with the 6, right? And then we are done. Oh, job well done, everybody. 3 over square root of theta times square root of theta plus 3 squared. Voila, box it with pride. Okay, good. Few more. Let's make sure you know derivatives of exponential functions, one of my favorites. So again, time for the quotient rule. So S prime of t is going to be, why don't you pause the video, do this one on your own. Okay, so we have low, d high, derivative of the numerator is just 2e to the t minus high, d low would still be 2e to the t over 2e to the t plus 1 squared. Again, factor out what you see in common in the numerator instead of multiplying out. So 2e to the t times, now what's left? 2e to the t plus 1 minus 2e to the t. Later, when you have to find extrema and critical values, you'll be grateful that you can factor your quotient rule derivative so slick. So put in the time now to make it a habit. These cancel. And then you're going to be left with 2e to the t over 2e to the t plus 1 squared. So yeah, you can get here if you sat there and multiplied this all out and then cleaned up, but it's just going to take more work. And later you're going to have much uglier derivatives. I'm so sorry, I know. And then when you're trying to clean them up, you're just going to run into so many problems. So get in the habit after the quotient rule. If you can factor out, do it. Do it, do it. Okay, yes, we're skipping example D. You actually can't do it in unit 2, you need unit 3. So moving on to example E, S equals t cubed tan t minus square root of t. So in this case, we're going to have to apply the product rule because we have product of two functions here, t cubed and tan t. Now the nice thing with the product rule is that the order in which you apply it doesn't really matter because product rule involves multiplication and addition, and those are both commutative operations. So I just think to myself, the functions have to take turns having their derivative taken. So if you have the derivative with respect to x of f times g, they just take turns. So you can do f prime times g plus g prime times f, or you could do g prime f plus f prime g. It doesn't matter, just so long as you don't have two derivatives at the same time. You'll never have f prime and g prime at the same time. Okay, so here we go. S prime of t, t cubed, it's your turn. Okay, so derivative of t cubed is 3t squared. Then leave tangent t alone, it's not his turn. Plus, now leave t cubed alone, you already had your turn. Derivative of tan t is secant squared t. Good. Minus, and then I told you the shortcut for the square root, 1 over 2 rad t. I don't know, do we clean this up more? I don't think so. I think it looks great. Let's just leave it alone. 3t squared tan t plus t cubed secant squared t minus, I wouldn't factor, I know you're probably like, you told me to factor. I wouldn't factor the t squared out because you can't factor it out from everybody. So just let's leave it and call it a day. Okay, last one's so gorgeous. Oh, it's not the last one, I'm lying. We have 2 more. Okay, this one's so gorgeous though. Y equals cosine x over 1 minus sine x. Okay, so y prime of x, or dy dx, whatever you want to write. Quotient rule time, here we go. So we've got low D high, derivative of cosine x is negative sine x. Anything that starts with any trig function, its derivative is negative. Cosine, cosecant, cotangent, all those derivatives are negative. Minus high, D low, derivative of the denominators, derivative of 1 is 0, derivative of negative sine x, the negative stays, cosine x, over low. Okay, now nothing I can factor out, so I'm just going to distribute, okay? So if you can't factor out, then distribute. So what is this going to give me? This is going to give me negative sine x plus sine squared x plus cosine squared x over 1 minus sine of x squared. And I have negative sine of x plus, the minute you see sine squared x, cosine squared x, you should go ding, 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 that's 1 over 1 minus sine of x squared. But you guys, isn't this the same as 1 minus sine x? So I can cancel it with one of the 1 minus sine x's in the bottom, right? This will cancel. Now this is just to the first, and we have 1 over 1 minus sine x. Wow, wow, wow. Isn't that beautiful? I love it so much. Okay, last one. Here we go. F of t equals e to the t times secant t minus t. So product rule time, f prime of t. E to the t will take your derivative, which means we do nothing. Leave secant t minus t alone. Plus, and then e to the t, it's not your turn. You already had your turn, even though it doesn't show. Derivative of secant t is secant t tan t. Derivative of negative t would be negative 1. Good? Okay, perfect. I'm noticing I can factor out e to the t, so let's do that. And then that's probably it. I don't think there's going to be any like terms to combine. So secant t minus t plus secant t tan t minus 1. Voila. And that's it, you guys. How was that? Were you able to do a lot of those derivatives on your own? Okay, make sure you memorize that quotient rule song, because I really feel like it's been working for me. Over 20 years, I still use it. I teach it to my students. So there you have it. It's good stuff. So that's basically our AP Calculus Unit 2 review. We've hit all the key topics: rates of change, definition of the derivative, estimating from tables, continuity, differentiability, and then all your basic derivative rules. But like I said earlier, if you want more in-depth lessons, then check out my AP Calculus Unit 2 playlist, because I have full lectures on every topic there. And don't forget to give this video a thumbs up, subscribe if you haven't already, follow me on Instagram and TikTok, Math with Professor V, and I will be back soon with Unit 3 review. I'll probably put these guided notes up on my Patreon if you're interested in downloading them, and the link for that is in the description. Bye, guys.